Good morning, students. Welcome to Computer Aided Design class, course code P20DE102, lecture 2, classroom discussion topic on hardware integration and networking. I am Rakesh, assistant professor in Department of Mechanical Engineering, KITS Warangal. Before going to explain hardware integration and network topic, let us see the lecture outcomes for this topic. After completion of this lecture, student will able to learn the following lecture outcomes. Let us see the first lecture outcome. One is discuss hardware integration and networking. Lecture outcome 2 is differentiate twisted pair cable, shielded coaxial cables and fiber optic connections. Lecture outcome 3 is distinguish between star LAN, ring LAN and bus LAN networks. Let us see the topic, that is hardware integration and networking. The integration and networking between the various components and accessories of a system ensures the success of CAD/CAM installation. In CAD/CAM, there are lots of applications where networking and hardware integrations are required. CAD/CAM is interdisciplinary by nature and its functions are distributed among various departments such as design and manufacturing in many organizations. Here, hardware components are motherboard, CPU, RAM, hard drive, graphical processing unit, the graphic processing unit, heatsink, and optical drives. This etc. These are hardware components. In this department, must communicate together and have access to common databases. Files, data, multimedia are comes under networking. Is to share common resources and accessories such as plotters and printers. Stand-alone workstations are most often networked together and to central computing facilities. The need to expand a CAD/CAM system by adding new workstations in an incremental fashion necessitates networking. It is also common to have a need to network devices that complement each other. For example, for example, in the system, it is connecting a high-end CAD/CAM system to a low-end system to allow database transfer. Local area networks are the main communication technology available in hardware integration and networking. Here, LAN stands for Local Area Networks. A LAN is a data communication system that allows various types of digital devices to talk to each other over a common transmission medium. In this, we are using three different types of cables. Low cost and low performance LANs use a twisted pair cable. The second one is co-shielded coaxial cables and third one is fiber optic connections are the used for higher speed communications. Let us briefly discussing about these three types of cables. The first one is twisted pair cable. Let us see the first figure. Uh, Twisted pair cable. Wires are twisted together in pairs. Each pair would consist of a wire used for the positive data signal and a wire used for negative data signal. It is a combination of both wires, that means positive wire and negative data signal wires. Any noise that appears on the positive or negative wire of the pair would occurs on the other wire. We need to change another wire because the wires are opposite polarities. These are 180 degrees out of the both wires. When the noise appears on both wires, it cancels or nulls itself out at receiving end. These twisted pair cables are divided into two types. First one is shielded twisted pair cable. Second one is unshielded twisted pair cable. Here, shielded twisted pair cable means twisted pair cables are most effectively used in a system that uses a balanced line method of transmission. The cables with shielded are called shielded twisted cables. Uh, Commonly abbreviated is STP. STP stands for shielded twisted pair cables. The another one is unshielded twisted pair cable. Cables without shields are called unshielded twisted pair cables. Uh, Commonly we are calling as UTP, unshielded twisted pair cable. Twisting the wires together results in characteristics impedance for the cable. UTP, these type of cables are used in Ethernet, used in computers and telecommunication systems. Let us see the second one. The second one is coaxial cable. It consists of two conductors. It consists of two conductors. The inner conductor of the coaxial, the inner conductor of the coaxial cable contained inside the insulation. Inside the insulator with other conductor waves around it. Other other conductor waves around it, providing a shield. An insulating protective coating called jacket. You can see it. This black color symbol coating is called jacket. It covers the outer conductor. The outer shield protects the inner conductor from outside electrical signals. Let us see the third one, fiber optic cable. It consists of thin glass fiber that can carry information at frequencies in the visible light spectrum. Typical optical fiber consists of a wire, a very narrow strand of glass called cladding. Typical core diameter in optical fiber is 62.5 microns. This is the brief discussion about different types of cables used in hardware integration and networking. The first one is twisted pair cable. These twisted pair cables are divided into two types. First one is shielded twisted pair cable. The short name is STP. Second one is unshielded twisted pair cable. The short name is UTP. Second one is coaxial cables. Third one is fiber optic cables. Here three different types of LAN topology available. The first one is star LAN configuration or star LAN topology. Second one is ring LAN configuration. The third one is bus LAN configuration. Let us discussing about star LAN configuration. Let us see the sketch. A star topology is designed with each node. Each node means file server, workstations, and peripheral. Peripheral means accessories. That means printers or scanners connected directly to a central network hub, switch, or concentrator. You can see this figure. These computers and printers all are connected to the central workstation. You can see the second figure. These all computers are connected. All computers or workstations or printers are directly connected to the concentrator hub, and it looks like a star connection. It gives star connections. Here, data on a star network passes through the hub, switch, or concentrator before continuing to its destination. The hub, switch, or concentrator manages and controls all functions of the network. It also acts as a repeater for data flow. This configuration is common. This configuration is common with twisted pair cable. However, it can also be used with coaxial cable or fiber optic cables. In the Starland configuration, we are using three different types of cables. That is twisted pair cable. Second one is coaxial cable, and third one is fiber optic cable. Already we discussed in previous slide. Let us see the advantage of Starland configuration. Easy to install and wire. The second one is no troubles to the network when connecting or removing devices. The third one is easy to detect faults and to remove parts. It is very reliable. If one cable or device fails, then all the other will still work, because uh, in the Starland configuration, each and every workstation directly connected to the hub. So one workstation failed, remaining all are in working condition. Less expensive because each device only need one input or output port and wishes to be connected with hub with one link. Easy fault detections because the link are often easily identified in Starland configuration. Let us see the disadvantages of Starland topology or Starland configuration. It requires more cable length than a linear topology, because in this workstation directly connected to the hub, so it requires more cable length than a linear topology, means bus topology. We will discuss in coming slides. If the hub, switch, or concentrator fails, nodes attached are disabled, because concentrator is the central unit. So if the central unit fails, the entire system will be disabled. More expensive than linear bus topologies because of the cost of the hubs or concentrator, etc. If hubs goes down, everything goes down, because in concentrator hub is the heart of the entire system. If hub goes down, everything goes down. None of the devices can work without hub. Hub requires more resources and regular maintenance because it's the central system of the star. The next one is ring LAN configuration. You can see that figure. A ring topology is a network configuration where device connections create a circular data path. Each network device is connected to others like a points on a circle. You can see here this workstation is connected to these two computers, and it makes one circular path. Together, devices in a ring topology are referred to as a ring network. In a ring network, packets of data travel from one device to the next until they reach their destination. In this ring LAN configuration, it transfers data from one system to another system in a circular path. Most ring topologies allows packets of travel data only in one direction called unidirectional ring network. Sometimes the data permits in other directions, so move in either direction. The type of direction is called as bidirectional data. Let us see the advantage of ring LAN topology. All data follows in one direction, reducing the chance of packet collisions. A network server is not needed to control network connectivity between each workstation. Let us see the data can transfer between workstations at high speeds. Additional workstations can be added without impacting performance of the network. Let us see the disadvantage of ring topology. All data being transferred over the network must pass through each workstation on the network, which can make it slower than a star topology. The entire network will be impacted if one workstation shuts down, because here are all workstations are connected to each other and makes a circular path. So the entire network will be impacted if one workstation shuts down. The hardware needed to connect each workstation to the network is more expensive than Ethernet cords and hubs or switches. The last one is bus LAN configuration. You can see the figure. This indicates the bus LAN configuration. In this, a type of topology in which all the workstations, printers, servers, scanners, and laptops are connected to a common cable. The common cable is also known as a bus. The cable which is used to connect computers is known as coaxial cable. When the data is sent from any computer, for example, uh, this computer send the data to another computer. It is broadcast to all the computers. The data contains MAC, MAC address also. So when data reaches the destination computer, then if the MAC address match, then data is received. But if the MAC address of the data destination computer is different, then the data is forward to other computer. Then when no MAC address match, then data reach to the end of the bus cable and bounce back. To solve bouncing of data, terminators are used at both ends of the cable. Let us see the advantages of bus LAN configuration. First one, low cost. The first advantage, low cost. Only one limited length of coaxial cable is needed to make the connection between computers. Coaxial cable also inexpensive as compared to fiber optics. The setup cost of bus topology is also low as compared to mesh and star topology. Second advantage is adding a new node. It is easy to add new computers and devices to the network. The newly added device can start working as it is. Not extra setup of the network is needed. The two cables are joined by a concentrator. The two cables are joined by a connector to add a new computer to the network. It is also easy to remove any node, and network performance will not affect removing any node. Next one is less cable length. In a bus topology, the length of the cable is less as compared to the star topology. The data is transferred easily if the cable length is small. Next one is no need of hub and switch. There is no need for a hub and switch to connect computers. All nodes are connected via coaxial cable. A print server and file server can be added to the network through the cable as well. Let us see the disadvantages. The first one is terminator is required. Terminator is necessary for making network terminator is necessary for making network in bus topology. If a terminator is not added, then data is bounced back and collide with other data of computers. The second disadvantage, troubleshooting. If there occurs any error in the network, then it is difficult to judge in which location the problem is. If the cable breaks, then whole network will stop working. Next one is maintenance cost. On increasing the number of nodes connecting to the network, problem of maintenance is created. Bus topology works fine for few computers. Bus topology works fine for few computers, but adding more computers creates a problem, as only one computer can send a message at a time. So wait time may increase if there are many computers are connected. The next disadvantage, not good for high traffic. Bus topology can only work fine for a small number of computers, and it is not ideal for large traffic of data. On adding more nodes, the performance of the network becomes slow. The last one is network security. As all the computers receive signals from the source computer, so it is not good in terms of security. Any computer can read the data transferred in the network, and hackers can easily get data by connecting to the network. These are the few advantages and disadvantages of bus LAN configuration. The advantage of bus LAN configuration: low cost, adding a new node, less cable length, no need of hub and switch. Disadvantage of bus topology: terminator is required, troubleshooting, maintenance cost, not good for high traffic. Last one, network security. This is the brief discussion about distinguish between star LAN, ring LAN, and bus LAN configurations in the hardware and networking system. Uh, After having completed the discussion on hardware integration and networking, now students should be able to learn the following lecture outcomes. Lecture outcome 1 is discuss hardware integration and networking. Lecture outcome 2 is differentiate twisted pair cable, shielded coaxial cables, and fiber optic connections. The third lecture outcome is distinguish between star LAN, ring LAN, and bus LAN networks. The students are required to required to follow the textbook, required to refer the topic in the following textbooks. First one, Ibrahim Jaid and Shiva Subramaniam RR CAD CAM Theory and Practice, second edition, New Delhi, Tata McGraw Hill 2010. The reading chapter number is 2.6. You can also refer Another book that is CAD CAM Computer Aided Design and Manufacturing by Jimmers, Emory, W. Groover, Michael.